Hey guys, it's Miss Johnson and I'm here to bring you our next notes video for Unit 8. Today we are in Unit 8, Note 6, which is covering the Pythagorean Theorem. So that is our learning target for today. I can apply the Pythagorean Theorem. So on the top of the notes page, we have the example talking about the Cyclone roller coaster at New York's Coney Island. It's one of the most copied roller coasters in the world. Since it was built in 1927, 7 people have copied the roller coaster on their parks. The first drop is about 85 feet tall, and from the bottom of the roller coaster to the bottom of the first hill is 127. I think that's supposed to be a 27 there. There we go. 127 feet. So use the Pythagorean theorem to estimate the length of the first hill. So here's what we have. We're going to draw ourselves a little picture, and you're going to draw pictures a lot in this unit today, so just keep that in mind. That's always a good thing when we're talking about triangles. So we know that the first drop is 85 feet tall. So I know that from the ground to the top of the first drop, it's 85 feet. Oops, 85 feet there. Then I also know from the bottom of the roller coaster to the bottom of the first hill. So bottom of the roller coaster to the bottom of the first hill is 127 feet. And we want to know what's the length of the first hill. So what's this guy right there? Okay, so now we're going to assume that the tower that goes straight up in the ground make a right angle, which makes it a right triangle. And since it's a right triangle, we can use the Pythagorean theorem. So we're going to have 85 squared plus 127 squared is equal to c squared. And then I square both of those. 85 squared is 7225. 127 squared is 16,129, and that's equal to c squared. Then I add those two together and I get 23,354 is equal to c squared. Taking the square root so that I have c by itself, I get 152.8 is approximately my c. So it's about 152.8 feet long. So that brings us into the Pythagorean theorem. If you don't remember the Pythagorean theorem from your earlier days of math, back in 7th grade and 8th grade when you probably first looked at it, this is what it looks like. A squared plus b squared equals c squared, and it only works when we have right triangles. A and b are the two legs, or the two sides that make the right triangle, and c is always the hypotenuse, which is the longest side, or the one across from the right triangle, or the right angle. So one phrase that you may not have heard before is a Pythagorean triple. Pythagorean triples are basically just three side lengths that make a right triangle. If we know that they fit the Pythagorean theorem, then we know that they make a right triangle. So we can call them a Pythagorean triple. So let's take a look at number 1. It says find the missing side lengths of the following right triangles. If necessary, we're going to write our answers as simplified radicals. That piece might be new for us today. So we'll talk about how that comes into play. Okay, so in number 1, I know A and I know B, so that means C is my question. So if I put it into the Pythagorean theorem, I've got 8 squared plus 15 squared is equal to C squared. 8 squared is 64, 15 squared is 225, and that's going to be C squared. Putting those together, I get 289, which is c squared, and then take the square root of that. 289 happens to be a perfect square, so I'm going to have 17 is equal to c. In number 2, I have 18 for A and 24 for B, so 18 squared plus 24 squared is equal to c squared. Again, I have 18, which is 324, 24 squared being 576, equaling c squared. And putting those two together, I get 900 equaling c squared, and I take the square root. And the square root of 900 is 30, so c is equal to 30. Taking a look at numbers 3 and 4. In number 3, I'm given A and I'm given C, so be really careful about the values that you're given. So what I have here is 10 squared plus B squared equals 25 squared, and B is the one that I'm trying to find. That's the missing value. So now I'm going to have 100 plus B squared equals 625. Sorry, I almost wrote that down wrong. 625. Then I subtract 100, and I get b squared equals 525, and take the square root. So b is equal to the square root of 525. Now, here's the thing. We need to go back to those original directions that say write your answer as simplified radicals. A lot of times, probably up until this year, you would just plug in the square root of 525, make it an approximately equal to sign, and round your decimal off. We're not going to do that here. What we're going to do here is we're going to break it down like we did back at the beginning of this unit. So I'm going to split up 525. 525 is the same thing as 25 times 21, and 25 is 5 times 5. 21 is 3 times 7, and I can't break those down anymore. So what I need to consider is the fact that I have a pair of 5s that can come out front, and then I'm still left with the 3 times 7, which is just 21. So I have b is equal to, and I can use an equal sign because I have not made an approximate decimal. I'm keeping it as a simplified radical. So this is 5 times the square root of 21. That is my missing side length there. Let's try number 4. In number 4, now we have b and c, so I'm looking for a. A squared plus 11 squared equals 21 squared. That's a squared plus 121 equals, where did it go? 441. There we are. And then I subtract the 121 minus 121, and I have a squared is equal to 320. So then I need to go ahead and break apart that 320 because now I'm taking the square root. So when I break apart that 320, I started with 32 times 10. Whenever I end in a 0, I like to do 10 just because I think it's easy. That gives me 4 times 8. That gives me 2 times 5. I got to keep going over here for a while. This is 2 and 4. This is 2, 2, 2. These are two 2's. This comes down to be a 2. This comes down to be a 5. So holy cow, that's what's under my radical. Now I'm going to take out my pairs. I have 1, 2, 3 pairs of 2's. So I have a is equal to 2 times 2 times 2 outside because I had 3 pairs. Still have the 5 left over underneath. Put those back together. 2 times 2 times 2 is 8. So I have 8 square root 5. All right. So now let's move down to the next part where it says we determine if the following side measures form a right triangle. So what we're deciding is, are these things Pythagorean triples? Okay, are they Pythagorean triples? So here's the thing. We're going to put these into the Pythagorean theorem, recognizing that the largest one always needs to be c. So I have 20 squared plus 21 squared equals 29 squared. And what you're asking yourself is this true? When I square these two and add them together, do I get that number squared? That's what you're trying to figure out. So let's figure it out. In number 5, I have 20 squared, which is 400. 21 squared, which is 441, and 29 squared, which is 841. And when I add those together, I get 841. That is equal to 841. So I'm good. My answer here is yes, they do. In number 6, we have 8, 10, and 12. 12 is my c value, so I have 8 squared plus 10 squared equals 12 squared. And again, I want to ask myself, is this true? So 8 squared is 64, 10 squared is 100, 12 squared is 144. That's 164 equals 144. That is not true. Big mark through that, making it a not equal to sign. So your answer here is no. They are not a Pythagorean triple. Let's try the next one. In number 7, 16 is my largest side, so that's my c. So I have 9 squared plus 12 squared equaling 16 squared. So that's 81 plus 144 is equal to 256. Adding those together, I get 225. And 225 and 256 are not equal. So your answer there again is a no. And one more practice questions of these. 26 squared, or 26 would be my largest side. So I've got 10 squared plus 24 squared is equal to 26 squared. And I want to ask myself if that's true. That's 100 plus 576 equals 676. And this time, 676 equals 676. That is true. So your answer here is yes. They do make a triple. All right. let's flip it over to the back, and I'm actually going to stop our video for this part right here, and we will come back together and finish the last part in the next video. Thanks for listening. We'll see you tomorrow.